Hello everyone, my name is Ivy Byes McKenzie, and in this short training session I'll be walking you through a wireless shark analysis of the two wireless frames that we received from our instructor, number 8 and number 36, 136, sorry. Number 8 is an unencrypted frame, while number 136 is an encrypted frame. Basically, I will be explaining the difference between the both. And then also I would be explaining each frame, the communication part at the different layers of each of the iOS model. Please pardon the noise in the background. It's just my kids that I'm currently watching as well. But I will just get straight into it. So first things first is basically looking up your frame. But honestly, you can also just on the side like scroll down or scroll up and forth, and then select whatever frame you're trying to go to. But since this one is literally like a bunch of frames, which is relatively what happens. But you can click on frame 8 if you want, or literally, because we won't be doing that for 136, you'll just type in frame dot number and then space and then equal sign and then a number of whatever frame you're trying to get to. Plus, also the nice part about Wireshark is it gives you a green bar or a red bar, as you saw previously before, whether you're putting in the number or putting in the command properly. All right, so the frame should pop up at the very top. You'll just double click on that, and all right, all these options and headers will appear. From there, we'll start from layer 2. Data link, basically. So when I expand the IEEE 802.11 data, you expand that, we will be able to see the source MAC address. I don't know if you guys can see it all that well. Sorry, my camera is in and out here. But you'll be able to see the source MAC address from over here. And then you'll also be able to see the destination MAC address as well. The source MAC address basically identifies the transmitter device, while the device MAC address identifies the receiving device. This is important because the data link layer basically ensures that delivery between the devices are on the same local network segment. In this case, basically just Wi-Fi. And then you'll go over here, and then you basically kind of shorten it so it doesn't get in the way when you're trying to look at all the other headers. The next one would be layer 3, network, and then we'll click this logical link control. You'll have to double click these just to get everything. So below the logical link control, you'll see DSAP. Try to make sure you guys can see that, and then SSAP, the snaps over here. And these all just indicate the payload type, in which case which points to the IPv4 packet, which you can, after that, directly just literally hit IPv4 packet. You just have to double tap that and then scroll down for this one at least. For us to get your source IP and also your destination IP. Basically, sorry, I'm trying to adjust the camera sometimes. But the network layer uses these logical addresses to route data between the networks. And then these MAC addresses are only valid locally. IP addresses allow the packet to reach devices anywhere across interconnected networks though. Okay, and then we'll just go back up here and go back up here and close it. And then we'll also close the logical link control. And then after layer 3, we'll go to layer 4, transport. Sorry, I was just reading this part. But transport. So you'll click the transmission control protocol and you'll expand that. Over here, you'll be able to see the ports that's available that we have. The source port, which is 20 on my device, and then destination port, which is 1105. And then ports just identify which application or service should handle the data once it arrives, basically. It's pretty cut and dry for that. And then after that, you'll click line-based data. This is basically layer 7, the application layer. Basically, you're just looking if you could see the payload, but you shouldn't. But the thing is, you can, because as we said before previously, frame 8 is unencrypted, so you'll be able to see the actual text of what is being sent to the actual user itself. And then I'm gonna scroll over so you guys can see all of it. But yep, you'll be able to see everything that's written down or sent through here. It basically demonstrates how it's important to encrypt, because you end up seeing private information that you're not supposed to be seeing. Okay, but we'll close out of this because this is basically it, and then we'll hit exit. I don't know if you guys can see that, but you'll exit, and then basically you'll do the same thing as we did previously before, and you'll type frame dot number and then space. Sorry. And then equal sign, and then it's 136 this time that we'll be doing. Okay, so now the frame 136 appears, and you just double click that like we did previously before with the other one, and you see how we have way less options compared to how we basically have less layers to actually go in and stuff like that compared to the unencrypted frame. Because remember, this is the encrypted frame. So we'll double click on the IEEE 802.11 data header, and then from there you'll be able to see the source MAC address and the destination MAC address as before. And then well, you'll basically, all this is basically the same information, but you'll be able to see those information. And then let me close out of it. And then for data, oh, sorry. And then if some of you guys are like wondering why you'd be able to still see that information, is just because even when encryption is applied, the device is on a wireless LAN, so it's still needed to deliver the frames on layer 2. So either way, it would still show the information. And then what's it called? You won't see the layer 3 and 4 evidently. And then the only layer, well, the only other one that you see is basically data, which is the encrypted part, which would be basically the application layer, I would say, honestly. But literally, this is basically encrypted, so you can't tell what the message was or private information was to get sent to the user and stuff like that. So those are basically the two differences. Basically, to summarize and conclude everything up, Wireshark basically reveals clear information from layer 2 all the way through layer 7, especially when traffic